Good afternoon, everybody, and thank you for joining this fourth webinar in the second Generation Eurocodes Webinar Series with the NSAI. And I'm delighted to introduce Jim Mansfield for this webinar. So over to you, Jim.
Okay, I'll just share my screen at the moment. I hope everybody can see that.
Perfect. Yeah. Thank you.
Okay. So basically, I'm talking today about Eurocode 1990 part. 1990. Sorry, that top slide is an error there. I'll move on to the next slide. Talking about the Eurocodes, I'm talking about EN 1991, which is the Eurocode for actions, and basically is dealing with the actions. And this is a generic slide of the Eurocodes as a whole. And basically, there are symbols for each of the particular Eurocodes. The Sigma sign is for basis of design, which I spoke about a couple of weeks ago. The loaded beam is for actions, and then there's reinforced concrete, there's steel, there's timber, there's masonry, there's foundations and geotechnical work, there's seismic actions, there's composite actions, there's aluminium, and there's glass. And glass is a new Eurocode which hadn't been in the previous series at all. So we've got a series of Eurocodes. We've got 11 Eurocodes there at the moment, and they're divided into about 65 parts. So this is the interaction between them with the symbols and the coloring that Europe use. So the two head Eurocodes, or the main head Eurocode is the basis of design, EN 1990. It's followed by actions and structures, and it's a lot of parts, and I'll be talking about that primarily today. Followed by that, there are 7 Eurocodes dealing with materials: concrete, steel, composite, timber, masonry, aluminium, and glass. And in fact, there's a technical standard out on fiber or on membrane structures, but that hasn't yet developed into Eurocode. This shows the last one as a technical standard, but is actually will be a Eurocode. And then there are 2 other general Eurocodes which apply to most types of structures. In Europe, there's EN 1997, which is geotechnical design, and EN 1998, which is seismic design. And luckily enough for us here in Ireland, we don't have to worry about seismic design. That's not a concern of us for normal building structures that fit into the overall trust of the codes. EN 1991 is actions and structures. And these are some symbols and color representations given by Europe. But basically what it does is, as it says there, it provides information on all actions that should normally be considered in the design of structures. Actions refer, for instance, to forces applied directly to the structure, resulting from the building's self-weight, from fire, from snow loads, from wind loads, thermal actions, traffic loads, and they also apply to accidental situations. There's also temporary actions, during execution and so on. And so there's a number. So they're what we're dealing with today. And this is Eurocode 1. This is all the parts. Eurocode 1 has 12 parts. Parts 1 to 9 are general actions and structures, and then there's part 2, which is traffic loads and bridges. There's part 3, which is actions induced by cranes and machinery, and there's part 4, which is silos and tanks. And the main parts of the Eurocode, we had 7 of these before, and I'm speaking today on the assumption that most people will know the Eurocodes. I'm not trying to explain everything in them to any great extent. We had 7 before in Eurocode EN 1991. Part 1, we had Part 1.1, specific weights of materials, set weights of construction works and enclosed loads of buildings. Part 1.2, actions and structures exposed to fire. Part 1.3, snow loads. 1.4, wind actions. 1.5, thermal actions. 1.6, actions during execution. 1.7, accidental actions. And then there's two new parts which have come in. Part 1.8, actions from waves and currents and coastal structures, and part 1.9, atmospheric icing. And the situation with all these Eurocodes at the moment is that they're all in place. The documentation is generally approved for each of the Eurocodes, and we're in a state of getting final approvals on some. Final approval has come on others, and then national annexes have to be prepared, because each of these Eurocodes will have within it what's known as a set of nationally determined parameters. And the nationally determined parameters are points which member states can bring in and put their own value in, and there will be a number of these, and they're significant enough in parts of the codes that will come in, and these have to be determined nationally, and then a national annex is produced which incorporates all the nationally determined parameters for any particular Eurocode, and that will come in and that will be produced at this stage. And that is to be produced. The timeline of this, we're now at the end of Q2 of 2026. These documents will be produced in 2027, with national annex by about Q3 of 2027. I'm getting mixed up there. And the old current Eurocodes will be withdrawn by about March 2028. So we're actually quite close, and we're working at the moment to produce these national annexes, but there is a lot of work to be done, a lot of work to be done within the next year or so. The national annexes will be derived. There are sometimes recommended values in the Eurocodes, and we will pay attention to what our neighbours in the UK are putting forward. We will change that in places. We certainly in some of these instances, I imagine we will change it, and we will pay attention to what other countries are doing. So there will be a set of national annexes which will be read, as I say, for Eurocode 1 with these 12 parts that are there at the moment. So the key changes that have taken place over since the first Eurocodes, titles have been modified and updated to some extent, and some movement of material from one code to another. For example, some documentation went from EN 1991 Part 1, Part 7, accidental actions, into EN 1990 and the robustness section of that. So there's been an update of titles. The codes have all been put together with a common structure so that they all look very familiar. When you open one, it looks quite like the other one. So there are design situations, classification of actions, representation of actions, how all of that comes across. Two new parts have been brought in, which were based on ISO, the International Standards Organization standards. Those are EN 1991-18, actions from waves and currents and coastal structures, and EN 1991-19, atmospheric icing. And then, as you may be aware, in EN 1990, there is the basis of design. There are a number of annexes to that for the different types of structure. So consistency has been brought in and carried across with those relevant national annexes of EN 1990. And so there's a lot of work has gone on in the background changing things. Many of the codes haven't changed all that much, but certainly there are some which have changed. So just to talk then about EN 1991 Part 1, which is actions on structures, it's the self-weighted materials and building loads. So there has been some update of definitions, i.e. a tributary area on a beam or on a column. One thing which has happened is that in the previous Eurocode, there were two tables. One set out what the imposed load categories for buildings were, and the second table put what those imposed loads actually were. And they have been coordinated into a single table, and work is taking place currently on this and the production of the Irish National Annex for EN 91 Part 1, Part 1, where we're putting values. And basically, that table has been extended a little bit. I'll come to that in a moment with some additional information and classes. But, you know, we had a class here for domestic and residential buildings, and we divided it in class A1 for dwellings and class A2 for other residential buildings. And that will be maintained, and there will be different values applicable for both. Another significant change in 1991 Part 1 is that there is a single table for horizontal loads on partition walls and on parapets. And there had been a modification of the National Annex of EN 1991-11, which brought in loads, not only parapet loads, but also loads, point loads and partitions and UDLs and partitions, and they will all be incorporated within the one document. There's been an update on partitions treated as imposed loads, how these are worked out and so on. There's updates on the modification factors. There's an area modification factor, which is less than 1, and then there's another reduction factor based on the number of stories within a building, and that too is 1 or less. And how these are to be used is to be changed, and they have to be looked at in an Irish context again. And again, those formula will be looked at, and there is a nationally determined parameter in relation to the use of these. One annex, vehicle barriers and parapets for car parks, was removed. And so now this is a general slide, which you know, I showed the same slide when I gave it when I gave my talk 2 weeks ago on EN 1990. But basically, the verbal forms used in the Eurocodes, they use 4 verbal forms with different requirements of compliance and so on. Shall is a requirement strictly to be followed and from which no deviation is permitted. Should is a highly recommended choice or course of action, and it's subject to national regulation and or any other relevant contractual provisions. Alternative approaches could be used if technically justified. May expresses a course of action permissible within the limits of the Eurocodes. Can expresses possibility and capability. It's used for statements of facts and the clarification of concepts. And this applies to all the second generation Eurocodes, not only EN 90 and 91, but 92 to EN 19100, etc. So these verbal forms, and these replace what were known as principles and application rules in the first generation Eurocodes. Some more content. They've put in some more information on garages for vehicles, particularly with a gross vehicle weight greater than 160 kilonewtons or 16 tons. That would really be storage of lorries, etc. So that's another category. There is consideration being given to G1 and G2, which are lighter vehicles, the vehicles over approximately 3 tons, and the loading there has to be looked at. There's an additional class of helicopters. New subcategories have been added for stairs and landings in buildings of different types. And so when you're looking at a domestic building, you will get a loading on the floors of those buildings, but you'll also get a loading for the stairs and landings. And similarly, they've included a category T for terraces and balconies. So they will have to be looked at and brought in. So there's a number of different areas brought in there, which hadn't been in the first generation of Eurocodes. So as I said earlier, that there had been two tables dealing with imposed loads in buildings, but these have been amalgamated to one, which will be a nationally determined parameter, and which a subcommittee of our own is going through those particular values at this stage to come up with a recommended value for the Irish National Annex. Also for horizontal loads and partitions, walls and parapets. Some more clarification on tributary areas and the use of the reduction factors was mentioned before. And moving onwards, then a key change to EN 1991-12, actions and structures exposed to fire. They've clarified some definitions. The scope has been clarified, in particular the non-coverage of the possible installation and maintenance of sprinkler system, the conditions of occupancy of buildings or fire compartments, and the use of approved insulation and coating methods. And then there are formula and relevant diagrams given as simplified rules for the determination of a reduction factor that can be applied to the fire load on a building. So there is information, and again, this would need to be read in its entirety rather than looking at it as an individual document. There's an Annex E, fire load densities, fire growth rates, and has been revisited and has brought in a factor which takes into account different active firefighting measures such as sprinkler detection systems, automatic alarms, etc. And this can modify factors. But the use of this will have to be verified and approved within the Irish National Annex, and whether Annex E, for example, can be used is a decision which has yet to be made in the production of the National Annex for that document. There has been further information in Annex C on the thermal action of localized fires. In Annex G, a model has been introduced to evaluate a virtual solid frame, and an Annex H has been put in on thermal actions for structural fire loads of timber structures, which is read with a part of EN 1995. They all remain normative, and the national annex has to be prepared. So in the Irish National Annex, permission may be given to use some of the informative annexes, or permission may be given, or statement may be given that they may not be used, and that is yet to be formulated. So we're in a state of transition at the moment from the first generation to the second generation. 1991 Part 1, Part 3 is a snow loading code, and it has been changed to some extent, and the previous code differentiated between continental and maritime climates, with maritime climates being principally Ireland and the UK. That's still there to some extent, but they've changed the wording and changed the layout of the code to some extent. So they've brought in new models which are closer to the physics and were based on experimental data available for European climates. They put in some additional types of roofs. We had situations where we dealt with drifted and undrifted snow, but that has become now to balance an unbalanced snow. So there is a change, and that's consistent with the ISO requirements and also the American requirements. Exposure coefficient has been updated to account for the increase of snow load in sheltered areas of a roof. snow coefficients generally have been revisited, and a new snow model for pitch roofs has been introduced. And for flat roofs, the extent of the roof dimensions is taken into account, as are the presence of solar panels. So there are changes brought in mind in what we're working on at this stage and so on. So this has been coming in, so there's been a significant enough changes there. And a couple of years ago, the Irish Met Office carried out a study of snow loads in Ireland, and there will be a new snow map, which is slightly different from what was our previous snow map introduced. The forces don't generally increase significantly, but there may be a change in the distribution over the country. So that's something we will be dealing with. And again, as I say, a national annex will have to be prepared for this one. They've also brought in an updated model for cylindrical roofs, with accounting for variations in the snow load positions. They brought in a model for domes and multi-span roofs. This has been revised because in some instances you could get a situation where the snow load could exceed the depth of the roof, and that wasn't appropriate. And this is changing. And then drifting of obstructions has been taken into account, and intersecting pitched roofs. So there's additional information, additional figures will be given for snow models on the roof of buildings. So this is roof abutting and close to taller construction works is how you work out and what your snow loading is and the various values that would apply adjacent to a higher roof and so on. And there you have a number of situations which will come in. One applies where I need to look at the full diagrams and so on, but basically there's two different situations applying. Then EN 91 Part 1 Part 4, the Wind Actions Code, there's been significant changes into that. This is a code that going through the process, both Ireland and the UK opposed some of the recommendations and voted against it, but it was accepted. But a new Irish national annex will have to be prepared, and that national annex will be similar, I would imagine, to the UK national annex. Work is going on, and there are some people who are sitting on groups developing both codes and so on. So there is changes are going to be made, and this would be a significant enough change. General changes have extended the field of application for buildings from 200 meters up to 300 meters. And you can determine the mean velocity and turbulence intensity of wind situations up to a height of 300 meters. There were two procedures in the current standard for determining a structural factor CSCD, and they've been unified in informative annexes F and H. Treatment of crosswind and torsional actions in susceptible buildings are included in the informative Annex G, and there is reference to atmospheric icing in the informative Annex E, and wind actions in silos and tanks has also been increased. That hadn't been in it and had been in the silos and tanks code before. So there are changes in there. There will also be, as for snow and the thermal actions, new Irish loading maps brought into the next generation Eurocode based on studies carried out recently by Met Éireann in relation to the Eurocodes and so on. So the further changes here, they've brought in many values of aerodynamic coefficients for types of structures not in the current standard. There are 3 new normative annexes, so that means there have to be adhere to pressures on surfaces, pressures on walls, and forces on structures. And that would be relatively similar to information that we had previously, but presented in a different matter. And then a new annex on the responsive steel lattice towers guide mass has been added. This was a transfer from part of EN 1993, the steel structure. And then there are 3 new annexes dealing with wind tunnel tests, deriving wind speeds from measurements of meteorological stations, and probabilistic methods for wind action. So there are significant changes, and again, a complete national annex will have to be produced. And the timing on that is tight enough at this stage. EN 1991-15 is thermal actions. They've added some definitions. The rules of applications have been clarified and improved. They've given guidance on how to determine the temperature components and temperature differences of different structural members within a structure, whether it be a building or a bridge. Buildings has been a new presentation of temperatures, and there's a new approach given for the consideration of uncertainties related to the initial bridge temperature or of a structural member at the relevant stage of constraint or restraint or completion, which is important for the design of bearings and joists. And then the elevation of the vertical components of temperature differences with nonlinear effects on bridge decks. There's an improved presentation given. There's maximum and minimum uniform bridge temperatures. This is a nationally determined parameter which is yet to be looked at and put into our national annex. But there are 3 types of bridge decks considered: steel decks, composite steel and timber structures, and concrete decks. And then there's a temperature range for a maximum and a minimum value for these types. So a steel deck type has to be designed for a temperature perhaps 40 degrees more than a concrete bridge type, and similarly lower values when you get into minimum temperatures. These are new Irish isothermal maps, a minimum one on the left and a maximum one on the right, and this shows the minimum values that have to be, or the minimum or maximum values that have to be taken at different parts within the country. So the minimum ones are ranging from about -10 at the western seaboard to -18 sort of in the eastern Midlands, and the maximum temperatures sort of around 34 degrees somewhere around Kilkenny, Laois and so on area, and 30 degrees around the western seaboard. And they can be compared with the older map, which was in the first generation Eurocode, IN 1991, Part 1, Part 5, 2003. And it was also in the previous British standards and so on, because this is an extract from a map that includes Ireland and the UK. And in that, the minimums were around -7 down around the southern seaboard to -16 up around Monaghan, Cavan, Fermanagh, etc. And the maximums have gone up, were reduced, so they've gone up since this map, the old map. This was 28 and 30, and now we're talking of between 30 and 34. So these have been revised, so there will be changes. So the new lowest had been -18, new highest 34. So there's a significant enough difference to be taken there. In 1991, Part 1, Part 6 is actions during execution. There's update and clarification of the scope of the document and the assumptions within the document. There's a reference to the use of product standards for auxiliary structures and equipment. e.g. false work, temporary works equipment, scaffold. So there's a lot of things, and relating that back into this. The design of auxiliary structures has been clarified, improved description of design situations, and a limited update of the classification and representation of actions. There's an update of the determination of the climatic actions, and there's additional considerations on actions during execution, such as imperfections, lateral stability, dynamically applied actions, and an Annex B, actions and structures during alterations, reconstruction, or demolition, has been removed. And there is a new code, EN 9090 Part 2, dealing with assessment of existing structures. So they gave a little bit more guidance on how you determine climatic actions. If something is happening for less than 5 days, you can base it on reliable meteorological data covering a period that includes the entire planned duration of the activity. If it's less than a year but greater than 5 days, you take account of, where applicable, seasonal variations by seasonal factors. So depending on where it is, you can consider those. Or if the works are taking place over more than a year, you use the characteristic values from the appropriate part of EN 1991, but you neglect seasonal values. You can use threshold values if it's agreed by the relevant authority or for a specific project and so on. So you can consider this, and this is basically where the decision to start or continue an execution activity is based on checking whether the values of that action will be met. So it gives you openness in there as to what might be done in terms of determining the loading. EN 1990-117, accidental actions. There's limited changes as compared to the previous version. There's clarification and improvement of some clauses. It's improved its compatibility with EN 1990 Annex E robustness, which relates to strategies for accidental design situations. So they've rearranged the categorization of consequence classes, and consequence classes are extremely important in terms of the accidental actions that have to be taken into account. There's clarifications on impact from vessels on rivers, canals, and seagoing vessels. Addition of ship impact formulas if they're non-ice class vessels. Clarification about internal explosions, and a new Annex E on actions from debris. EN 1991 Part 8 is a new standard on coastal structures and so on. So most significant items of this, there's a comprehensive definition of environmental sea conditions, which are water level, wave conditions, currents, and there's detailed information given in one of the annexes. They implement a hydrodynamic estimate approach, HEA, which is a methodology to assess meta-ocean parameters that relate to the consequence class of the structure and the local hydrodynamic conditions, and they implement different design approaches. So this is a complex area, so it would need to be dealt with primarily on its own. And the purpose of this is that the methods and requirements for design, it can be outlined depending on the hydrodynamic estimate approach level, the design approach level, and the consequence class. So depending on the severity and the nature of the environment, you then approach the design for this. So this is a table within this. Again, a national annex will have to be produced. So for a low HEA level and a low DA level, there's a certain design approach can be done, and if you've got a higher one, you use different values and so on. So these are different ways that can be adopted within the Eurocode, and that will have to be looked at from an Irish point of view. Sorry, EN in 1991, sorry, this should be 19, not 18. Ice load, this is atmospheric ice load. This is again a new standard where ice loads are determined and classified according to ice classes for both glaze and rime, glaze ICG, rime ICR, because these vary. Wind action combinations is considered. A height factor is considered for glaze ice, and most information for this will be left open for the national annexes. And basically it will be a body like Airgrade under the ESB who are concerned primarily with this, and for towers and masts, you know, for television, etc. This would be important. So there is an Irish group looking at this, and an Irish national annex will be provided. It's based on an ISO standard, but it is been made more compact and is written in a Eurocode style. It gives various ice thickness for glazes for different classes, so it varies from 10 millimeters to 50 millimeters or upwards. And then the ice mass that goes on to something from 0.5 kilograms per meter to 50. Generally, we would find that in Ireland it would be the lower classes, and these are the kind of diagrams that show how this is produced. EN 1991 Part 2 is the bridge loading, and that's a more specialist. I'm not going to go that in any detail here. There's an extension of the scope and field of application and change of title. It includes other civil engineering works, but not buildings. There are some changes for geotechnical items. There's new wording, mainly related to railway traffic loading. It addresses the requirements of the European Railway Agency for the revision of some clauses. It deletes some old annexes. It updates one annex, Annex E, and it's adjusted in line with consistency of EN 1990 Annex A2, that's the Annex A dealing with bridges and other Eurocode bridge parts, following a horizontal group on bridges proposals. So it was looked at to see that the set of codes were coherent as an entirety. There are new sub-clauses, clauses dealing with road and railway traffic for static load models for geotechnical structures. Track bridge interaction has been looked at. Includes a basis of design for noise barriers at railway lines, which has been brought across from another code. Includes some new methods and materials, footbridges and timber structures, and deals with some information in a new Annex G relating to EN 1990 Annex H in relation to dynamic actions and pedestrian-induced vibrations and so on. So there's some new information brought in. These are loads depending on the type of weight across a bridge. Very, very weak traffic, I'm not sure, exceptionally dense traffic, pedestrians per meter squared, and so on. So you can modify factors, and that information will be given in the new Annex G. Annex EN 1991 Part 3 is actions just by cranes and machinery. So there's clarification in the scope of that. It sets some new additional principles and requirements and actions transferred from cranes and machines at the interface with their supporting structures. There's an update of the definitions. It relates to Annex A5 of EN 1990. Treatment of in-service wind has been added and clarified, and some former normative annexes have been reduced because they've been put elsewhere in the document and so on. There's more user-friendly guidance given from cranes travelling on fixed runways for two important cases. The main case, the use of technical data file for cranes designed according to European crane product standard, and then if there is no crane product standard, older cranes, there's an Annex B which gives advice on how to do it. There's an improved and updated classification of typical bridge and gantry cranes for supporting structures, and there's an addition of guidance on actions from travelling wall cranes, as this is in a new Annex C. EN 1991 Part 4, silos and tanks. Clear definition has been given between with different requirements for different types of silos according to an action assessment, construction complexity, consequence of failure, and the stored bulk solid behavior. There's a new user-friendly structure with simple routes throughout the document. It's a more rational basis for prescribing characteristic loads. The revised standard has been based on more physics and less empirical work. There are steps towards consistency with Annex A4 of EN 1990, which deals with silos and tanks. A new section added on silos with an inverted cone, and new rules on rectangular silos, and new clauses in asymmetrical conical sizes and an overpressure. Finally, I think this is the last slide. There's a clear distinction made between symmetrical loads and vertical silos and special cases where there's unsymmetrical pressures and high slenderness, large eccentricities, etc. So there's a new annex given to set out how that has been used, and that is given in a series of flow charts. So there is one more. And then the eccentricity limits for silos, it depends on small filling and large filling, etc. And this will be followed through in design process. So that is the end, if you like, of this. It's a very quick overview of 12 codes. And if there's any questions or any issues that anybody wants to raise, please do so.
Jim, I'll just chip in there. It's David Gall, and apologies, I wasn't available at the beginning of the session, but it seems like you were all very more able than I to use the link and get connected. So, like I say, apologies to you and everyone that I wasn't there at the beginning to introduce you properly. But thank you very much indeed for starting, and thank you very much for that very, very interesting presentation, Jim. So yeah, absolutely. I did put a message in the chat partway through just to remind everyone to raise any questions as Jim went through. I can't see any questions in there immediately, but I'll be quiet for a couple of minutes and just see if anyone else wants to raise a hand or just open up the mic with a question for Jim.
Just while we're waiting for questions to come in, and thanks David for hosting us today, and Jim for the presentation. I just, as I did for the last few webinars, I would like to just put some information into the chat about the funding available, the NSAI fund that's available for standards related work. So for travel expenses, accommodation, etc. for standards related work. I have a few slides and I could show them as well in case anybody missed them in the last few. So again, just take your time to get some questions in, and I'll just run through a few slides here about the fund. All the information is in that link I sent to you. And I'll just share my screen. So hopefully you can see that now.
Yeah, you can. Thanks, Helen.
Great. So as I said, and your members of Engineers Ireland are encouraged to apply for the fund for standards related work. The fund has been available for this work for the past number of years, and the fund is open for travel this year, 2026 to technical committee meetings that are organised by a recognised body, and you can use the fund towards flights, hotel stays, meals and transportation. So the aim of the fund is to support members to attend these International Technical Committee standardisation meetings taking place this year. How you apply is there's an application form, but you can simply contact our finance team at finance@engineersireland.ie, and the fund will close at the end of the year. So just just to raise awareness that the standards development provides you with the opportunity to make a positive contribution to the industry and improve your professional knowledge. And we encourage you to play an active role and share your expertise by participating in the standards development. And we actively encourage you to participate in the continuous maintenance, development and implementation of standards, and also to remember that you record the attendance at the meetings as and on the committees as CPD hours, and also you can record this session and any of the sessions you've attended over the past number of weeks on this series as CPD hours. So that's all for me. Just a reminder of that fund. And our finance team would be delighted to hear from you if you're interested in it. There is some selection criteria that are outlined in that link that I've popped into the chat. But otherwise, thank you, and I'll hand back over to some Q&A. Thank you.
Just to say to people that I think there will be organised by Engineers Ireland or the NSAI or both further seminars later in the year which would deal more specifically with parts of EN 1991 in more detail, because I think it needs that. I think this kind of seminar where we have half an hour, 45 minutes dealing with 12 codes is insufficient to get across the level of detail, and probably insufficient for anybody listening to be able to formulate questions or to go through the code. But I think it is intended that there will be later in the year, probably around the time national annexes are being developed, further seminars with more detailed scope dealing with the various parts, maybe not every part of EN 1991, but with various parts, certainly as I see it, on the general parts, on the wind parts, on snow, probably through TII on bridges, etc. So there will be more information available to people later in the year, and the details of that will come through NSAI or Engineers Ireland at an appropriate stage.